Okay guys, so I'm trying to make this video for everyone, and it's about confirmatory factor analysis, and I'm gonna use Amos. So let's see what I can do here. Trying to share the screen, so let me bring up the Amos first, and then we'll move on with confirmatory factor analysis. So I have just brought up the Amos, and I'll be sharing the screen with you very soon. Just bear with me 2 seconds there. So let's see. So I'm utilizing Zoom for this video. It's an amazing software so far. So let's see. I think the video has been shared, and let's see what's going on. Brilliant. So I have my video here, and I've got my volume uh, set. Just bear with me 2 seconds. I'm just trying to. I'm sort of like struggling with this. So let's see, starting off with this confirmatory factor analysis. First things that we want to do here, we want to go ahead with the confirmatory factor analysis. Then we'll be doing the reliability, validity, and model fitness, and then we'll be looking at other things. So first thing we want to do is to bring this variable symbol here. So we want to go and click on this variable thingy, and I'm gonna just put it here. So if you look at this diagram that I have created, I have just clicked on the page and I have clicked twice. So the first circle that is here, that is called latent variable, and the squares on the top are the observed variables, and the circles on the top are the error measurement. So this is the beauty of Amos, that it gives you the error measurement as well. So I'm gonna have at least 3 variables, latent variables, as per 3 questions, because I've got 3 questions in my data. So I'm gonna go on to this symbol here, the one which is with the circle, rotate the indicators. I'm gonna just dance them around. So you see they start dancing around if I click on them. So they are. Now I want to just relocate them. So I'm gonna hit on this truck, and I'm gonna hit on this preserve symmetries. So that kind of icon here, I'm gonna do that. I'm gonna drag these circles right in the center so that it looks better. So now we are done with the sort of like our model that we are trying to work out with confirmatory factor analysis. Now we want to bring in the data. So we go to this screen here, select data file, go to file names, and we want to bring our data. So we had this data 2 here on my desktop. So I'm going to select that. That will be imported to Amos. And then I'll be going to this one here, the icon here, list variables in data set. I'll click on that, drag them on the left hand side so that I can bring them in. So these small variables, they have to be dragged into the observed variables. So OC1, OC2, and OC3. Then P1, then P2, and then all I want to do is to click on that and drag them all the way across to the page, and that will be appearing into the circle, inside the circle rather. So yeah, P3 is, oops, okay, let's do Control Z. And Amos is so friendly, even if you do Control Z, the command is reversed. So I'm gonna drag SS1 here, and then I'm gonna drag SS2, and then I'm going to drag SS3. So for all my questions, I'm going to give some name, and I'm going to click on these circles, and this window will appear. So the first one I'm giving OC, that's done, and close the window. The second one I'm giving P, close the window. And the third one I'm giving SS, and close the window. So the model is almost set. I'll go to the top tabs, I'll go to the plugins, I'll go and click onto the unobserved variables. That is our measurement error measurement. So that's the model ready. Now what we want to do we want to make sure that covariances are there between these latent variables. So I'm gonna click on this finger and try and select all these three latent variables, OCP and SS. And once they've been selected, I'll go and use the draw covariances. So see, covariances have appeared between these variables, or if you say constructs. So we have got the covariances between the constructs. Everything is sorted. I just want to make sure that I've saved the file. I've saved it so many times on my desktop. So I just want to go back in the session of Jan, and I'll be putting practice quiz. Okay, let's put that this way. And I'll save it. Everything is sorted. I have made sure that the covariance is there. I just want to go back and click on this piano kind of thingy, analysis properties. This will bring up this sort of like window, and I want to go and click on the tab that is output. I'll be selecting minimization history, standardized estimates, squared multiple correlations. All these three have been selected. Once it's been done, I'm ready to analyze my data. I'll be clicking on calculate estimates. So once I calculate estimates, there is a red button that appears here, and that's right at the top here. I'll go and click on the standardized estimates and click on this button. And see, I have got all my covariances, factor loading appearing here. So all this factor loading, I'll be picking and analyzing to see if my results are significant or not. So we have been shared with few files. I'm going to one of those files in my documents. So I want to go for the reliability and validity. So the file is in my download sort of like a folder, and I'm trying to work out where is the file. So that file will help me in analyzing whether I've got the significant relationship between the construct or covariance. So let's go for this construct reliability and validity. So there is a file called construct reliability and validity. For some reasons it doesn't appear on the zoom, and it is not visible, and that's the challenge that I'm facing. So just bear with me 2 seconds. I'll try and open a new Word file, and I'll bring them up here, and I'll show how I'm working. So first thing, if this file is sort of like what do you call it, visible to you, I'm assuming that the two files that I've got here, which have got some formulas in there, it is embedded with the formulas, they're not appearing. But the one that I have opened, the new one, so I'll just close all the windows. I'll go back and I'll just bring up the new file. Once the new file is there, I'll go into the embedded file, the one with the formulas, and I'll bring up all the information. So standardized factor loading kya hai? That's what I want to bring. So standardized factor loading, that's the one that I'm trying to find. And I'll go and put the covariances. If you see the covariances from the AMOS that I have in the covariances, I've got 0.85, 0.87, and 0.83. So kya hai? 0.85, 0.87, and hang on, that's 0.87, and that is last one, 0.83. So that's the covariance between the factor loading between the sort of like two constructs between within the same construct. That's the one with the construct number OC. That's we have got latent variable and factor loading. Now with these factor loading, we will put all the three values into the Excel file that's called construct reliability and validity, which has been shared. So if you go there and you put all the three items in there, that will give you the construct reliability and convergent validity. And you want to understand, if it is greater than 0.5, then it is significant. If it is lesser than 0.5, that's not significant. So that's something we want to go and do. So I'm going to take this 0.85, 0.87, and 0.83 into the Excel file, which is not visible to you. But if I put 0.85, 0.87, and 0.83, this will give me the construct reliability and convergent validity. So I've got my numbers here, 0.887 and 0.723. So let's see, just 2 seconds. 0.887 and 0.723. So my composite reliability for the first factor loading ability is, I'll go back to my 0.887. Okay, that is 0.887, and the convergent validity is 0.723. Okay, 0.723. That's awesome. So I've got it here. Now, once I'm done with this, I want to find more things here. I also want to find Cronbach alpha, and for that reason I'll be utilizing SPSS. So I'm just utilizing one construct and their factor loading. So I'll be closing this one here quickly. I'll be shutting my screen here. I'll be bringing up SPSS, which takes rather a few seconds. So what we are looking at a few things here. We are looking at convergent reliability. We are looking at Cronbach alpha, and we are looking at composite reliability. So we have already got composite reliability 0.887. All you want to do, put the covariances or the factor loading, all the three numbers or the measurements that you have got from the values of the factor loading into that Word Excel file that has been shared earlier, and that will give you the composite reliability and convergent validity. So if you look at the Word file is designed in this way: standardized factor loading, and I'll be just sharing the screen, just 2 seconds here. And then we have Cronbach alpha, which I'm just writing here for your alpha. And after Cronbach alpha, composite reliability, and then I'll just do one thing here. Okay, so SPSS is here, and just 2 seconds, I'll be sharing the screen again. So I'll take you back to the the Word file. And in order to give you an idea about the Word file, the one that I'm utilizing here, where I have got everything embedded, which is with the formula and graph. So I'll go to design, insert, and I'll be creating a table of 4x4 here quickly. So let's create a 4x4 table, and let's put it here: standardized factor loading, Cronbach alpha, composite reliability, and then we have got, after composite, convergent validity. Okay, convergent. Okay, I made a mistake here. I should have what have I done here? Hang on, 2 moments, guys. I know I had to create a column of 6x6 or more than that, because unfortunately the file is not appearing, it's not visible. So I have to do a bit of an extra work for you, but I will make it. I'm not going to give up on that today, not today. And how do I delete this one? Okay, so that's here. And let me go back to that file and see, there were 6 columns. Okay, so let's see 6x6. I'll go for 6x6. Let's see. So that's the already given file, right? So that's a bad one. Control Z. Not too good in these technicalities, unfortunately. Let's put the maximum here. So let's create the entire file here. So first one is standardized factor loading. So there's something here I've written. I'll pick that one, fill it in here, and then Cronbach alpha I'll be bringing here. I'll be putting the composite reliability, put it here, and I'll be going with the last one, That's a convergent validity, in which we have got variance, convergent validity. Let's put here convergent validity. Still I have missed out on one column. Unfortunate, very unfortunate. So, and then there is discriminant validity. So in order to just demonstrate, I'll be giving you here discriminant validity. All we want to do is to go back to our Amos, and let's see, I just want to bring Amos here. That's Amos here. So we want to go back to Amos. All we want to do is to go and look around this. Let me turn this way for you. It will become bigger. So we want to go and see this latent variable, and we want to look at the factor loading 0.85, 0.87, 0.83. All of them are here. If anyone is less than 0.5, then there is a problem. So that's something I don't want to discuss right now. I just want to tell you the method how to calculate. So we have got factor loading. Just to give you an example of one construct, one question, I'm going to calculate that. I'm going to put all these three figures into the file that has been shared, which I have repeated multiple times. That's the Excel file. And when you put all these three figures in there, you'll get two values: construct reliability and convergent validity, which you can come and record here. And when we are recording here, I'm just going to show you how am I recording. I'm recording it in this file. So if I was to go for the first factor, it was 0.87, 0.83, and the third one was 0.85. So the sequence does not matter, so don't worry about that. Once I have done that, I want to calculate the Cronbach alpha, composite reliability, and convergent validity. In terms of convergent validity and composite reliability, I've already got the result: 0.887. That is significant because it is greater than 0.5. The second one, okay, so second one that I've calculated, and that's convergent validity is 0.723. So I'll come back here and I'll put 0.723. Okay. And now we want to go for the Cronbach alpha. I missed out on the R. It's just Cronbach alpha. Cronbach alpha is so funny. Okay, so we want to go for the SPSS. I'll be bringing up SPSS here for you. Now I want to share the screen again, just because Zoom is not too friendly. Let's go for SPSS. So that's the screen of SPSS. I hope that's it. It's showing here. So I want to import the data. I want to go for file. I want to click on import data, and I want to go for Excel. So once I click on Excel, I've got the data too. That's how I'm working with. I go click OK. So data has been imported, and now it must be shared with you guys. Okay, so somehow the screen has stopped sharing, but I have put the data in. Now the screen is showing. So I'll go with one of these tabs. This is the sixth tab from the top. It says analyze, and if I go for analyze, I'll be going for scale, and in scale it's a reliability analysis. So I want to pick this one. So we were working on first question, and we want to bring all these little construct or factor loadings into the right hand side. Once we have picked up here, so we'll go and click OK. Once we go and click OK, we will have our Cronbach alpha, and that's 0.882. So, and this screen unfortunately is not shown. So I'll just go and click again and see if that screen can come here. So let's see, where's that Cronbach alpha gone? I hope, yes, awesome. So awesome. So this screen has been showing here 0.882. All I had done, I'll just go back again, just close this window for you. Yes, I just want to, okay, no, I don't want to save it. I just want to close it. So let's say no. So I've said no to this, and the screen has stopped sharing. So you get the point. You go to the SPSS, you go right on the top, analyze. This will open this window. You go to scale, and when you go to scale, you click on reliability analysis, and this is still with, and you click OK. and that will calculate the Cronbach alpha. And the screen is not showing for some reason here. It's not appearing for you guys, but if I just go and click on that again, share the screen and share the screen again, reshare it, it will come up. So 0.882 is my Cronbach alpha. So if you go for here and I want to bring my Word file, okay, hang on, come on, don't do that. 0.882. So now I have got 0.882. I've got Cronbach alpha, the composite reliability, I've got convergent validity. Now, when we are doing our discriminant validity, what do we do here? We want to go for the covariances, and what we want to do with the covariances, we want to see our AMS, and we want to see how many items are covariating with each other. So that's something I want to show you. So if I was to go back to AMS and I want to bring it back for you guys, okay, I want to come up here and I want to bring the AMS. So you see on this screen where I have got the latent variable. A latent variable, when it has a relationship, it's covariating with the other latent variable. There are two liners here. One of them is 0.62, the other one is 0.67. You see this value. And this one is 0.66 and this one is 0.67. So we will have at least three covariating of sort of like what do you call this thing, hang on, just bear with me 2 seconds. Discriminant validity. So this is 1.62, 0.66. These are two. This is a pair. OC and P 0.62, OC and SS 0.67, and then comes OP and SS 0.66, and then OC and SS 0.67. So let's go with 0.62 and 0.67. So what we want to do, 0.62 and 0.67, I'll remember these values. I'll just go back to my Word file. 0.62 and 0.67, I come here. So what I want to do here, 0.62 is one of the covariating between the two, covariation between the 0.67, 0.67. Okay, so how do we go and calculate discriminant validity? That's the question. So what we do, we first try and get the square of both the values. So I'll be calculating the square of both the values, and once I have got the square of these values, what I'm gonna do, I'm gonna add them together and divide by 2. So that's something I'm going to show you how I'm gonna do it. 2 seconds. So I'll bring up the calculator here. Where's my calculator gone? That's the calculator. So I hope it's just sharing. No, it's not sharing. That's the issue I'm facing time and again. But I want to come up here and I want to use calculator and the screen that I have. So the Word file is not here, but 0.62 was the value. So if I go with 0.62 into 0.62, it gives me a value 0.3844. So I'll be putting this value 0.3844 on the Word file. 0.3844, and the square root of 0.67 is coming as 0.4489. 0.4489. So if you look on the screen now here, when I'm trying to work out the maximum shared variance and average shared variance in the discriminant validity, I have done what? I have taken the square root of both the values, and these two values are here. So in terms of variances, the bigger value here, this one will be, hang on, I'll just highlight it here. That will be maximum shared variance. But if you go for the average shared variance, I'll just add them together and divide it by 2. So I hope my calculator is shown here. No, it's not. So I'll be showing you the calculator. This is very challenging, I understand, but I want to do it. I just want to do it. So I'll be sharing my calculator and be adding both the values. So let's see, 0.38, no, yeah, 0.3844, and then plus 0.4489 is equal to 0.8333 divided by 2. That gives me 0.41665. That's average shared variance, 0.41665. Let me copy it. And let me put it back where average shared variance can be there. So I'll be sharing my screen one more time, which is million times now. That's here. So that's my shared variance, and that's the value. Oh, 0.4 was 0.4112, I guess. 0.4112. So that's the shared variance. So you want to do the same process with all the three constructs that we have, or as many constructs as you might have. Or as many questions as you might have. So we have three here. So once you go through every construct, you will find that there are a few values which are less than 0.5, and that shows that it's not significant. And this is where the problem with the model fitness will come, and reliability and validity. Let's go and see the model fitness. So we stop sharing and we want to go back to Amos, and we want to share the screen, and we want to bring the Amos. So this is our model, and we were trying to work out the factor loading. As I said, that we will be looking at a few things. The first thing is a confirmatory factor loading, then the reliability, validity, and the model fitness, and then we'll be looking at structural equation modeling, SEM. So let's go for this one, and we see the model is not fit because some of the values that we have got for our Cronbach alpha, and we have got some of the values for the convergent validity shows that they are less than 0.5, and that's a problem. So the model is not fit, and that's the hypothesized model is not consistent with the observed model on the screen that we have. So that's a big problem. I am so sorry, but once you have done so much work, you do feel like bad for yourself. So let's go with this screen, and we want to go with the model fitness. So before we go there, we want to just go at the top in the plugins. We want to go where? We don't want to go there. Sorry. We want to come here in analysis properties. We want to uncheck these things here. Minimization history, I would keep it, I guess. And I want to put modification indices. So once I put modification indices, things will change in the model. So things have changed in the model. And once the things have changed in the model, what I want to do, I want to bring my file back, because you see this has disabled. This has been disabled. This window I want to use to see the values, which will give me an idea about my model. So I want to go back to bringing the data in. So I'll go to this file here. I'll click on file and I'll bring in the data. So I'll go to the desktop. And once I'm in the desktop, I'll be going for January session, and there's no Word file. So that's a big one. So let's see where's the Word file. Hang on. Let's bring up the Word file again and go to PC, go to desktop, go to January, and there's no Word file. Why is it happening? So let me just shut everything and go back and see how can I bring my Word file here. So sorry, the Word Excel file rather. So I go here, I click in here, and I go to downloads. Okay, and there's no file there. Why? This is very strange. Just 2 seconds. Okay. Okay, so Zoom is giving me a message that it is about to end soon. So okay, now I am there. So I have done one thing. I have gone through the file, and now my model looks this icon has become active, the one that I was talking about, and this item is view text. So I'll go to view text, and I'll go to the second last option called model fitness. If I go to model fitness, it will bring this screen up here. So I'll maximize the screen, and we want to go through some of these values. And what are these values? There is a separate file for that, which I'll be sharing here, which will tell you whether the model is fit or not. So I'll be going with the file, and I'll bring it up for you. Just 2 seconds, because there are files that we want to utilize. And the file was, hang on, model fitness indexes. So this file is called model fitness indexes, and I'll try and share. If it can come on the screen here, it becomes visible, I'll be grateful. So let's see model fitness. Okay, so these are the values. So if the value of chi-square is less than 3, it will be if lesser than 3, it will be acceptable. There will be significant value if it is greater than 0.00 p value. So we want to go for chi-square, p value, GFI, AGFI, CFI, TLI, and root mean. That's called Ramsey. So these are the values as per this chart we want to verify with our model fitness. If it is greater than these values, it's a model fit. If it is less than, for Ramsey, 0.08, it is a fit model. And if it is lesser than 3 chi-square, it's a fit model. So let's see if we can bring up our AMOS, and we can bring up our model fitness file here, which is unfortunately not coming. I'll have to again share the screen for you guys and see. So if we go for the chi-square, see the p-value that we have here, and where's the file gone? Hang on, just 2 seconds. The file that I had brought up. So yeah, so if you look at the p-value, the first thing, p-value has to be greater than 0.00, which we don't have. So it shows, it rings the bell that no, our model is not too fit. And then we go for the chi-square, and chi-square here, let me see, chi-square has to be greater than, less than 3, and we see it's not less than 3, it's something too big. So that's another problem. Oh, yeah, so that's the chi-square, and it has to be, yeah, that's good. 2.6 is lesser than 3, that's fine. And let's go for the next one. And next one, we want to look at GFI greater than 0.90. Well, it's close to 0.9, close to 0.9. Okay, and after GFI we have AGFI, should be greater than 0.90. AGFI again close to 0.9. Not too bad, not too bad. That don't matter much, but that does ring the bell. Comparative fit index, that is CFI, should be greater than 0.90. And where's CFI? Yeah, that's greater than 0.9. So we are happy here. But as far as the other values are concerned, they're not too, sort of like accurate. So TLI greater than 0.90. Where's TLI? TLI close to 0.9, but we are not getting there. Let's look at the Ramsey. Ramsey has to be lesser than 0.08. So Ramsey, where are you? It's not the Pharaoh Ramsey, it is one of these. Okay, so it has to be less than 0.08, but we have a 0.12. That's a greater value, so our model is not fit. So what can we do to make our model fit? So in this model, let's see, we will go and look at modification indices, and we will play with these error measurements. Unfortunately, if your error measurements are not from the same construct, you cannot play with them. You cannot draw the covariance between them. So for example, I'll take you back to the AMS and I'll show you what I'm talking about. There's no single there is not a pair of errors that belong to one construct. E1 belong to construct 1, E7 belong to construct 3, E1 again 1, and E8 from 3. So if there was E1 and E3 from the same construct, I could have drawn the covariance, a covariating relationship between the two construct, and I could have sort of like balanced my model, but I cannot do that, unfortunately, in this circumstances. So let's go back to my, sorry, where am I? Let's go back to my AMS model. and share the screen. Okay, so it's coming up here. So if there was, like, say, within the same construct there were two errors, I could have drawn a covariance here between the two, and I could have sort of okay, just bear with me 2 seconds, and I could have sort of like calculated the model again. I could have gone back here and I could have tried to improve the model. I could have run the analysis again, the model again, and I could have, now the factor loading are different. Okay. Okay. Hang on, just 2 seconds. Let me click on those things and run the model again. And then I have to calculate. So now I've got different factor loadings. Now I'll go back to my screen up here and change a few things here. Sorry, I'll deselect these things. I'll select the modification indices, and this will disable all these values. And I'll go back to my model fitness, which I'm trying to do after calculating everything. Once I go back to model fitness, I'll go back to model fit and modification indices. And you see in modification indices, you have to pick the greatest value. So if I was to balance it, the greatest value is between E2 and E9, and that is 9.7. But they are not from the same construct. They are from two different constructs. So unfortunately, we cannot improve this model. So that's what we have learned about the validity, reliability, and model fitness. This model is not fit, unfortunately. This is not meeting the hypothesized model. The observed model that we have got on our AMS is not matching the hypothesized model. That's what the answer is. And rest of the details I've already given you. Now I'll be making another video because the time is running out for the path goal analysis, and that's something I'll be doing later in an hour or two, and we'll work on that. That is SEM. Thank you.